Assalamualaikum students. This recorded lecture is regarding the atomic structure. The first topic of the atomic structure. In atomic structure in AS, there are mainly three topics. First is about the arrangement of electron in shells, the configuration of the electrons, the subshells, quantum shells, orbitals, everything. And then atomic and ionic radius. And then the next topic is what? Ionization energy. So we are starting with the configurations of the electron, the arrangement of the electron in shells and quantum shells. So I'm going to share the screen with you people. When I'm sharing, you guys are supposed to like, subscribe and share my YouTube channel. जब मैं पढ़ा रही हूँ और आपको पता है कि जब मैं कहती हूँ कि मैं कर रही हूँ तो मैं कर रही होती हूँ, राइट? तो आपको फिक्र करने की कोई जरूरत नहीं है. If I'm saying that I'm gonna explain everything, means everything, all the explanation, all the past paper practice. You will find all the notes on my website, Chemistry by Zeenat, and for the topical, my website, the same. And you can get all the information on my website. And if you want to join my live sessions, you can even contact me. You can get information from my website. And right now, I'm going to share the screen with you people so that to save your time, you can stop, you can rewind, you can slow down the lecture. You can watch it through like your own way, your own pace, anything, right? आप क्या करोगे? शेयर करोगे. So I hope कि ये lectures आपको बहुत पसंद आए और आपकी full helpful. Like I want to help you out, but still, if you want to join my interactive session, you can contact me. So coming to the sharing of the screen and explaining, right? Now, when I'm sharing, I want to show you that the notes are, these are the notes, atomic structure. Atomic structure, yes. Look, I won't lie with you people. I've written like some are very well written. You can see the notes, right? Everything is well explained. But the first topic, when I was like, मैंने जरा देर से डिसाइड किया कि ये सब कुछ मुझे करना है ना, ठीक है? तो ये मैंने लिखा है, but like if I'm not happy with my own way of writing, I will share. Like ठीक है, सही है, मुझे भी पसंद नहीं है, but मैंने atomic radius ये मैंने ज्यादा अच्छे लिखे हैं, ये शुरू वाले अच्छे लिखे हैं, they are well described, but पता नहीं क्यों मुझे इतने अच्छे नहीं लग रहे. But yes, they are 100% complete, everything, right? So you will find all these notes on my website. But when I explain, I don't write on my notes. This you must know. I don't write on my notes. I will write on separate page. I will explain everything. But I will share again with you people so that you can see that they are given there. You're supposed to focus so that we can save the time. Like I will be focused on the teaching, and for the notes you will come to these. And when I am teaching, just focus on that, what is the concept, how you will understand, and how you will reproduce when you will be examined, right? So coming on a separate page. Yes. So when I'm starting, listen. Okay. The first thing in atomic structure is what? In atomic structure, the first thing is what? Atom. You know that atom has three subatomic particles: electrons, protons and neutrons. Yes. And as you know, you have done this in O levels. What you have done? The relative charge and mass. The relative charge, the relative mass of electron, of proton, of neutron. We know the charge of electron is -1, the charge of proton is +1, the charge of neutron is 0. And mass, electron is 1840 times lighter. Look, 1840 times lighter than one proton and one neutron. But one proton is equal to one neutron in mass. Almost, it's not exact. The most heaviest particle is neutron among these three, right? But in our system, it's a bit like generalization. We are not going into the exact values. So the mass of a proton is equal to mass of a neutron, and electron is 1840 times lighter. Right. Now, after doing this, we know another thing. Every atom, every element has two numbers. These two numbers. One is atomic number or number of proton. Where? In the nucleus of an atom. And what is the second number? This is atomic number. Huh? What is the second number? Mass number or nucleon number. What is nucleon? Nucleon means inside the nucleus. The particle inside the nucleus. What is there in the nucleus? Neutron and proton. Nucleon number. Sum of proton and neutron in the nucleus of an atom. Now, suppose it is fluorine 919. This is what? Proton, and this is what? Proton plus neutron. So if I subtract the proton, I will get what? Neutron. Like if I put the proton here, so 9 plus neutron is 19. So N is what? 19 minus 9, it's how much? 10. This is proton plus neutron. You know this. I hope you have done all these very well in your O levels. So, next point, look, next. Atom is neutral. Atom has no charge. Why? Why atom is neutral, no charge, electrically neutral? Why it has no charge, although it is made up of proton and electron? It has no charge. It contains proton, it contains electron, it contains positive, it contains negative. But atom is neutral because number of protons are equal to number of electron. The positive charge is balanced by negative charge. The positive charge is balanced by negative charge. Now, coming to another point. Look, this is nucleus. This, I think I should have done this in the beginning, but okay, I think you don't have any problem with these things. I should draw the atom in the beginning, but okay, done. It is nucleus. So what is there inside the nucleus? Inside the nucleus, there are proton and neutron, and these are called what? Shells. These are called shells. In these shells, what are present? Electrons. Now, now suppose I have an atom. I have an atom. Sodium. 1123. You know that these are protons. You know that these are proton plus neutron, right? So there are 11 proton, and since there is no charge, nothing, the protons are balanced. The charge of the proton is balanced by the charge of electrons. So there are 11 electrons. And since 11 plus neutron is 23, so neutrons are how much? 23 minus 11, it's how much? I think it's 12. It's how much? 12. So inside an element, like you can find proton, the protons are always equal to electron if it is an atom. If there is no charge. Like if I write water, is there any charge? No. What this shows that the electron protons are equal. Like if you have any molecule like calcium carbonate, no charge, this shows what? That inside calcium carbonate, the electrons are equal to what? Protons. In any particle, when inside the proton electrons are equal, it's not carrying any charge. Like it is not having any charge. Although it may be charged particle, like sodium chloride. It is positive and negative, but overall charge is zero, which shows that the electron protons are equal, right? So atom has no charge. The protons are equal to electrons, and the neutrons are what? Mass number minus proton number, you get the neutron. I hope you don't have any problem with this. Now, the next thing that you are supposed to do is what? Electronic configuration, your main topic. Electronic configuration. What you have studied in your O levels? 2, 8, 8, and so on. The capacity of the first shell, second shell, and third shell. Agree. But now we are going to explain this, like to do this in detail, right? So to explain this, what I'm going to do. Look. This is nucleus. This is nucleus. Nucleus contain what? This is first shell. Second shell. Third shell. Fourth shell. And you know, if I want to draw it more perfectly, you know, they get closer as they get far. Yeah, these shells, they get closer, but these all explanations are not in your course, so don't waste your time in thinking. But I will use this statement only at one place. Like you can see, it's like this. Yeah, it's like this. Kind of, right? Now, look. These are, I will use this again and again. So, look. This is nucleus containing what? Proton and neutron. This is nucleus. Having proton and neutron. And these are called what? Quantum shells. These are called what? Quantum shells. These are called quantum shell. First quantum shell, second quantum shell, third quantum shell, fourth quantum shell, fifth quantum shell. I hope 1, 2, 3, 4, fifth. Yeah. Sixth quantum shell. These are all called what? Quantum shells. My Q is not pretty. Wait. Quantum shell. Or main energy levels. Like they show the energy of the electron, right? These are energy levels. Now, quantum shell, and you know, they're not circular, they're spherical, right? Like look, nucleus, first quantum shell, second quantum shell, third quantum, like that, like spherical thing, right? So these are called what? Quantum shells, main energy levels, and they're represented by N. You know what is N? N is called principal quantum number. Principal quantum number. Now, it could be 1, it could be 2, it could be 3, 4. So this is principal quantum number 1. This is principal quantum number 2. This is principal quantum number 3. And now principal quantum number 4, principal quantum number 5, and principal quantum number 6. Do you get? Huh? Quantum number 1, quantum number 2, third shell, fourth shell, fifth shell, sixth shell. So these are quantum shells. Now, next. You know, as the electron, suppose the electron is in the first shell, then electron is in the second shell. The electron in the first shell, the electron in the second shell, the electron in the third shell, electron in the fourth shell, electron in fifth, electron in sixth. The electron is getting close to the nucleus or far? Far. Electron is what? Look. You know what is happening? Electron is getting close or far? Is getting far from nucleus. Huh? Electron experience less nuclear attraction. Look, this electron is very close to the nucleus. This electron is getting far, far, far. The more they are getting far, the less nuclear attraction they will experience. So the one which is close experience more nuclear attraction, less nuclear attraction, less. So if the nuclear attraction is more, look, if the nuclear attraction, like if I'm the nucleus, if I attract the electron more, the electron are close to me, I'm attracting electron more, the electron movement is less. The electron, less movement, more movement. As the electron is going far from the nucleus, their energy will increase. You know, two things are changing. They are getting far, their position is changing, their potential energy, their kinetic energy, both. When the electron is going away, like its distance, its positioning, what is potential energy? Energy due to position. What is kinetic energy? Energy due to motion. The electron close to the nucleus experience more attraction. If I'm attracted more, my movement would become less because I will be close to something. Right? So as the electron which are close, they experience more attraction, they experience less attraction. The one which are close, their kinetic energy is low. Look, the kinetic energy is low. Just say the energy is low. Like, don't even talk about kinetic energy. Don't even talk about potential energy. The energy is low and the energy is more. So if electron is in quantum shell 1 and electron is in quantum shell 3, more the principal quantum number, more is the energy. Larger the value of n, look, larger the n, more is the energy of electron and more is its distance from nucleus. Now, next thing. We know that these are quantum shells, the electrons are getting far from the nucleus, perfect. Now, the quantum shells contain subshells. Now, the question is why? Why the electrons are moving like this, moving randomly around the nucleus? Actually, the electron in an atom, they try to be as far as possible from each other. The electron, they are trying to be as far as possible from each other, and these electrons try to be close to the nucleus. We are not going to study all in these in too much detail, because if we are going into this thing, that's kind of quantum mechanics in detail. You will study that, like, if you don't want to do it for A levels, like in higher studies, they talk about that electron, the moment, this is circular motion, the electron movement, there everything is, the electrostatic forces of attraction are balanced by centrifugal forces. Like, there is too much inside it. We are not studying that much. But we must know that are the electrons randomly moving, or they have certain pattern, or like, what is the driving force about electron? Like, what is the reason why they're distributed in a particular way? The reason is the electron in an atom, they try to be as far as possible because they repel each other and they try to be close to the nucleus. And in search of that thing, to have minimum repulsion and maximum attraction by the nucleus, they have certain particular places, they have certain particular positions where they experience more nuclear attraction and less repulsive forces with each other. Therefore, we say that quantum shell contains subshells. What are subshell? Places where the electrons are present. But again, we say that quantum shell contains subshells and subshells contain orbitals. So the actual thing is what? Orbitals. Orbitals are the places where the electron experience maximum attraction by the nucleus for that electron and minimum repulsion with the other electrons. Right? Like this, like, suppose if you are living in your home, if someone asks you that where do you live, you will say that I'm living in Islamabad. Like, suppose, for instance, in this whole wide world, if you say you are living in Pakistan, the probability of finding the person who is living in Pakistan is more than instead of saying that he is on earth. Like, okay, you are on Earth and you are in Pakistan. Where probability is more? Definitely in Pakistan. When you say that I am living in Islamabad inside Pakistan, probability furthermore to find you, right? Like, take me as an example. I'm taking my own example. I'm in Islamabad. My probability to find is increasing. Now, if I say that I'm in G9 in Islamabad, probability further increase. I am living in this street. My probability further increase. I am living on ground portion of this house. Huh? Now, on ground portion, am I standing? Am I lying on the bed? Am I sitting? Like, what is the orientation? How I am oriented? Like, actually, we are trying to find, like, why we are doing the configuration of electron, why we want to know about the arrangement. We want to know that how the electrons are arranged, because if I will know about the arrangement of the electron, I can think about the reactivity of an atom. Because we know that if the electrons are arranged in this way, if they are close to the nucleus, it's very difficult to take them out. They will not react. But if they are far from the nucleus, they can be easily taken out. Now, there are some other things too. Like, it's not the only definition that close to the nucleus, so reactivity is less or more. Like, you can, like, they could be metal, non-metal, gain of electron, loss of electron. At the end, they all depend on how the electrons are, how they are arranged, what are their movements, what are their energy. Like, in an atom, if there is an electron, what are the points about electron? What is the distance of the electron from the nucleus? Distance. What is the movement of the electron? What is the energy of the electron? What is the distance of the electron? What is the orientation of the electron? What is the spin of the electron? So the quantum mechanics, they all do this, right? But we are not going to do in that much detail. But yes, the point is that why we are doing this, why we want to study about that the electrons are in quantum shell, they're in subshell. Actually, we want to find out that how the electrons are arranged. Because if you know about the arrangement of the electron, you would be able to think about the reactivity of that atom or element. So and secondly, why the electrons are in subshells and orbitals? Because they try to be as far as possible to minimize their own repulsion with each other and to be close to the nucleus to experience more attraction. Why the electrons are arranged in this particular way in subshells and orbitals? Again, I am repeating, the electron try to minimize the repulsion with each other, and they try to maximize their attraction with the nucleus. In this whole struggle, they are in subshells and orbitals, right? And once you know about the arrangement of the electron in the subshells and orbitals, you would be in a position to think about the bonding, the reactivity of atoms, right? Because the reactivity is linked to electronic configuration, electron arrangement, right? So quantum shells contain what? Subshells. Look, for quantum shells, I'm going to write just Q. Quantum shells contain subshells. S, P, D, and F. These are four subshells, right? The capacity of the S is 2, the capacity of the P is 6, the capacity of the D is 10, the capacity of the F is 40. So quantum shells contain subshells. Now, one thing that I want to share with you. You know, in the first quantum shell, there is just one subshell S containing 2 electrons. In the second, it's S and P. The S contains 2, the P contains 6. Right? In the third shell, there is S, there is P, and there is this D. Now, in the first quantum shell, 2 electron capacity, 8 electron capacity, then 18, and then again 18 plus 14 is how much? Wait a minute. 32. 32 electron, 32 and 32. Look, what is the capacity of the first shell? 2. This you have done in O level. 2, 8 and 8. No, it's not 8, it's 18. Right? This I'm going to explain. Don't worry. So 2, 8, 18, 32, 32, 32. Right? It's the same. Now, in the first shell, the 2 electron. You know, these 2 electrons are present where? These 2 electrons are present in the S. The 2 electron in the first shell, they are present where? These 2 electrons are present in the S. 8. Out of it, 2 are in S and 6 are in P. So 6, 7, 8. And again, 8 plus 10, 18. And now, look. S2, P6, D10, and then what? F14. 100% same situation. Like if I write it this way, that would be much clear. In 2, and then P6, and then D10, and then F14. In the next, exactly S2, P6, D10, F14. Same. S2, P6, D10, F14. Right? So quantum shell contain what? Subshell. But what you are going to add here? You will write 1. This is 2 and 2. Why? This is 3 and 3 and 3. I am writing, start thinking why. 3P, 3D, 3F, 4S, 4P, 4D, 4F, 5S, 5P, 5D. You know why? Because this is S of first quantum shell, S of second quantum shell, P of second, S of third, P of third, D. Look, like when they write this way, 3p6. What is the meaning of this? This is quantum shell, this is subshell, and this is what? Electrons in that. So quantum shell contain subshell. Like your house contain rooms. Rooms contain beds and chairs to accommodate you. So quantum shells contain what? Subshell. What is the capacity of S? 2 electron. What is the capacity of P? 6. What is the capacity of D? 10 electron capacity. F, 14 electron capacity. And you know the quantum shell contain what? Sorry, the subshell contain what? Orbitals. They contain orbitals. You know what is an orbital? Orbital is, look, orbital. Region around the nucleus which can contain 2 electrons with opposite spin. The probability to find electron is maximum in orbitals. Region around the nucleus which can contain 2 electrons. Region around the nucleus which contain 2 electrons. This is orbital. Every orbital has the capacity to accommodate only 2 electrons with opposite spin. Like an orbital is represented by a box or a dash orbital has capacity to have two electrons if one is spinning clockwise, the other spin anti-clockwise. Clockwise and anti-clockwise. Now, what is orbital? Look, principal quantum numbers contain what? No, sorry, quantum shells. So principal quantum shells contain what? Subshells. Subshells. How many subshells are there? Just 4. SPDF, right? The subshell contain what? Orbitals. Orbital has the capacity of how many electrons? 2 electrons. Like if Cambridge asks me, what is the capacity to accommodate 3p orbital? When they use the word orbital, 2 electrons, p subshell, 6 electrons. There is an MCQ which they have repeated some 2-3 times. The question is this, that which of the following statement is true about 3p orbital? And you know the first A option is it accommodate contains 6 electron, and most of the students go for this. No, it's incorrect. Orbital means 2 electron with opposite spin, although there is no question about the spin in the past paper. No. An orbital can accommodate how many electrons? 2. So if orbital accommodate 2 electrons, can you tell me that if I write subshell, or okay, I think I should go this way. Quantum shell and then subshell and then orbital. First quantum shell, n is 1. Contain just one subshell. You know this, 1s. And you know there is no difference between s orbital and s subshell. 2 electron. The s subshell and orbital identical, no difference at all. Now, second quantum shell. The second quantum shell contain what? Can you tell me? Second quantum shell contain what? 2s and 2p, and then 3s, 3p, 3d, and then 4s, 4p, 4d, 4f. So the second quantum shell contain what? 2s, 2p, and you know 2s same, no difference. But 2p, 6. If in p there are 6 electrons, so how many orbitals should be there? 2, 2, 2, because orbital can accommodate 2 electrons. So 2p6 is 3 orbitals. I'm going to write their name after some time. Wait a minute. 3 orbitals. So how many boxes? 3. How many electrons? 6. Each orbital 2. Each orbital 2. Right? You know what are these called? One is px, one is py, and one is pc. Why? Because of their orientation. This I'm going to explain after some time. Wait. So, first quantum shell contain 1s, no difference. Second quantum shell contain what? 2s and 2p. The 2s is same, but 2p, we know that it's 2p subshell. It is 2px, 2py, 2pz. Each contain 2 electrons. Now, if I talk about third quantum shell, n is 3. It contain what? 3s, 3p, and 3d. No difference, same thing. But this is what? 3px. How much? How? 3py, third quantum shell. 3px containing 2 electrons, 3py containing 2 electrons, and 3pz containing 2 electrons. And these are how much? 10. 10 divided by 2, 5 orbitals. Each orbital accommodates how many electrons? 2. So one box. So 3, and this is 1, 2, 3, 4, 5. So there are, in 2s, there are just 2 electrons. This is what? 1, 2, 1, 2, 2, and 2, and 2. And this is again 2, and 2, and 2, 2, and 2. Right? So if I go for n is equal to 4, then I will write what? 4s, 4p, 4d, 4f, and so on, so on, so on. Right. Now, one thing that I want to tell you. You know, the S is like this. Look, S is spherical. S is what? Spherical. It contains 2 electrons. If they ask me, draw 1s and 2s and 3s. So, is this S of first quantum shell, S of second quantum shell, S of third? This is small, this is large, much large. The only difference is, if this is 1s, the 2s would be like what? This. And the 3s would be like what? No difference. This is 1s, this is 2s, and this is 3s, right? Spherical, like nucleus 1s, 2s, and then 3s. Now, if we talk about p, you know, how is p? P is p orbital is what? Dumbbell. I hope the spelling is correct. Dumbbell shape, right? It's like this. Huh? It is like this. Dumbbell shape. Now this dumbbell, its capacity is how much? Just 2 electrons. But this dumbbell could be along x-axis. It could be along y-axis. It could be along z-axis. Z-axis. If it is along x-axis, 2 electron moving this way, and moving this way. Look, look, look. Moving this way, and moving this way. Getting the point? Px, Py, and Pz each have the capacity to accommodate 2 electrons. I want to share something with you. Wait a minute. I hope I find it. She Scandium. Not this one. Oh, this. Yes. Wait a minute. I hope there is no ad. Oh, You can see on the screen. Look, this is 1s. This is 1s. You can see this. Spherical. Now this is a bit bigger, 2s. Having two electron, 2s. 1s, 2s. Now look, this is 2px along x-axis. This is 2py along y-axis, 2 electron. And 2pz, 2 electron. Like in 1s2, then 2s2, then 2px2, 2py, 2pz. And now look at this. This is 3s. So big. 3px having 2 electron. 3py having 2 electron. After 3p, now there is this 4s. Oh, 3pz is left. Now this is 4s. There is no 3D. This I'm going to explain in my next video, right? But now there is the Z shapes are not, the 3D shapes are not in your AS course. I was just sharing this with you to explain. I'm leaving this, coming back to my topic. You can see this video again and again, right? Look, the thing that I want to tell you, I will wind up after this my lecture, and I will do the whole configuration in my next recorded lecture. But right now, what I want to share with you people, look, that this is what? Nucleus, then it is what? 1s, then it is 2s and 2p, and then it is 3s, 3p, 3d, then 4s, 4p, 4d, 4f, 5s, 5p. But actually, we know that I'm going to make it a bit small. It's like this. Look. Yes. Look, it is nucleus. It's like this. It's 1s. Agree? This is 1s. Now, look. This is 2s. Okay. This is 2px. Oh. This is 2px. This is 2py. This is 2pz. And now 3s, 3px, 3py. Great. Look, nucleus, 1s, 2s, 2px, 2py, 2pz, 3s, 3px, 3py, 3pz. And after this, there is 3D. 3D is not in our course. But one thing that you must know, S is spherical, P is dumbbell shape. Dumbbell does not mean that the electron is passing through the nucleus. No, the electron is in this area, in this area. Electron are here, electron are here. The electron are not coming closer. Why? They are repelling. They're trying to be as far as possible to minimize repulsion with each other, but they try to be close to the nucleus as more as possible. Now, our next topic is how you will do the configuration of each element. Right? So the next lecture is about configuration. Guys, इतनी एफर्ट कर रही हूँ, इतनी मेहनत कर रही हूँ, आपने क्या करना है? like and subscribe and share. Okay. So, leaving. See you in the next recorded lecture. Allah Hafiz.